you should see, my little math minions, you should see it says Module 2 Review, and there's some things already written in there. And I'm going to go through, and what I'm going to do, look at you, beautiful girl. Got her little tiara crown on. So, one of the things that we did in Module 2 was we went over dividing fractions. And if you remember, with dividing fractions, the thing to remember is keep, change, flip. Super important. Dun, dun, dun. Okay, so this is how we divided our fractions. Go with you, color blue. And then we've got 5/12 divided by 4/7. And right away, when we see that fraction and a division sign, we say, "Oh, stop it. Nuh-uh, we're not going to divide by fractions. That is not going to happen." That's when we write down K, C, F. And then we rewrite our problem. Remember, we do not try to do this in our head. You cannot try to do this in your head until you have been doing this for at least 20 years. Okay? Until then, you must write down KCF. You know what? I've been doing it like 40 years, and I still write KCF. 5/12, we keep it. 5/12. And now we change this, because we like to multiply. We like to multiply. Yes, we do. All right. And then we're going to flip this fraction upside down, the second one. So now it becomes 7/4. And now all we're going to do is multiply straight across. So 5 times 7 equals 35. And then 12 times 4 equals 48. And there's nothing we can do to simplify that. So we are good to go. Dun, 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 that's our answer. Now, a couple of things that keep throwing you for a loop are when there's a whole number and when there's a mixed number. So I want to cover that real quick. Here we go. 5/12 divided by 3. We're like, not going to happen. We want to K, C, F. And we also say fractions and whole numbers, they don't play well together. So we need to make this one a fraction. A whole number is just the numerator over 1. That's how we make it a fraction. Now we keep, 5/12, and then we change that. We're gonna multiply, and then we change this and it becomes 1/3. Now we've got 5 times 1 and 12 times 3. 5 times 1 is 5. 12 times 3 is 36. Easy peasy. We got ourselves an answer. This one really trips a lot of people up. Remember, for this one, there's a little step before keep, change, flip. You have to do 1, make an improper fraction. Then you're going to keep, change, flip. So we have to take this one right here and turn it into an improper fraction before we can do the rest of the problem. To do that, we do 7 times 2, that's 14. And then we add the 4, so that's 18. And your denominator stays the same. We don't mess with that. And then divided by 2/3. Now we do KCF. Don't skip a step, okay? I rewrote the whole problem for a reason. That's all of step 1. Now we do step 2. Keep, change, flip. Keep is 18/7. Change. We make it multiply, and then we flip it over. We got 3 halves. So we've got 18 times 3, 7 times 2, 18 times 3 is 54, 7 times 2 is 14. Okay, you can stop here for the matho, or you can simplify this and make it, turn it back into a mixed number. Okay, that is up to you. 14 goes into 54, 3 times? Leaving 12 14ths. Oops, I can divide both of those. So that's going to be 3 6/7. Okay? Matho will take either of these answers. So that's okay, because I know some of you are still struggling with this. I will tell you, by the time you get to 7th grade, you have to be able to do this. They will not accept improper fractions as the answer. It has to be simplified all the way. So work on that this year if you're still struggling with it. All right. Next up, we covered long division, and I know this is where everybody goes, go ahead, give me your ugly face. Give it to me. You hate long division, you know you do. Yep. Well, guess what? Too bad, so sad, you still got to do it. All right?
My worst nightmare.
I know. Somebody is always saying that. Well, let me tell you, it's really not as difficult as some of you make it out to be. If you know your multiplication tables, that's the key. All right? Like this first one is 5,634 divided by 6. If you know your 6's, you're good to go. Okay? So 6, we can't go into 5, but we can go into 56. 6 goes into 56 9 times. Because 9 times 4, or excuse me, 9 times 6 is 54. Right? We subtract, and that gives us 2. Bring down the 3. 6 goes into 23 3 times, because 4 would be too much. 6 times 4 is 24. That's how I knew it had to be 3. So that's 18. Five left over. Bring down the 4. Oh look, we already had 54 once. 9, 54, 0, done. 939. Now, here on this one, this is where you guys are like, I don't want to do this. Okay, I'm going to pause for a moment because I just noticed in my chat, Siri says I can't find it, and Natalia says class notebook correct. Yes, class notebook, collaboration space, teacher teach, so with this one, 27, that's where you guys are like, man, I don't know my 27s. Guess what? Neither do I. I don't know my 27s. I have to figure them out every time. So off to the side, you write 27 times 1, 2, 3, 4, 5, 6. Okay. I usually go to 5. And then if I need to, I go further. Where's my little thingy digger? Where's my dickory-doo? Come on. All right. Well, it won't let me do that, so I just have to be careful. All right. So 27 times 1 is 27. Times 2 is 54. Times 3, 7, 81. 4 is 108. 5, 20, 35. Yeah, 135. And then we'll go ahead and do 6 since I wrote it down. 6, 108, 150, 162. Okay, let's see if that works. Hopefully we won't need more. So 27 goes into 185. Looks like it's going to be 5 because 6 is too much. No, it's going to be 6. 6. Boy, my brain's not working sometimes. So 6. And notice I put it above the 5 because we have to keep things all lined up. So now we know that 6 times 27 is 162. We subtract that. We have 23 left over. Bring down that 2. Now we have 232. It's like, oh man. All right. Times 7 is, let's see, 160, so 70, 80, 189. And then 8, because I want to make sure that 189, okay, 180, 200, and 97 is 16. And then 9 would be more than we need, so we'll go with 8. 8. So that's 216. So now we subtract. We have 16 left over, and we bring down a 2. And look at that. 162. We have 6 again. Minus 162. 0. Bob's your uncle, and that's your answer, 686. It's not so much a big brain, Michael. It's more like I use my brain. Ooh, yes, I did. I said that. All right. We also looked at adding, subtracting, multiplying, and dividing decimals. So this should be too easy. So, remember, when we're adding and subtracting, we want to line, nope, that's not the color I want, that is this one. Line up the decimals. Every time. Always, when you're adding and subtracting, you have to line up the decimals. Notice that I did that when I wrote my problems. I just lost somebody. That's too bad. All right, 7 plus 8 is 15. So we put the 5 in the 1's place and carry the 1 that means 10. And then we go 2 plus 3 is 5, plus 1 is 6. We just keep the decimal exactly there. Adding is easy. Subtracting is easy. This one, we're subtracting. 9 minus 7 is 2. Keep our decimal right there. 4 minus 3 is 1. And 1 minus nothing is 1. That's our answer, 11 2/10. Now,
why is decimals more easy than division? Because you just have to add and subtract sometimes.
I don't know. I do not know. All right. And here we go. Multiplying. Here's the thing. For multiplying, we ignore the decimal. until the end. Then we go back and put the decimal in. So we pretend like there's no decimal there at all until we're done. So we just do this multiplication. 2 times 3 is 6. 2 times 9 is 18, which means we carry the 1. 2 times 2 plus 1 is 3. I've done my 2, so I'm going to put a 0 because we're going in one space. 7 times 3 is 21, so we carry the 2. 7 times 9 is 63, plus 2 is 65. 7 times 2 is 14, plus 6 is 20. I've done my 7, so now I'm going to put 2 zeros because I'm going in two spaces. 1 times 3, 1 times 9, 1 times 2. We add this all up. We get to the bottom of my thing. 6, 8, 5, 6, 7, 8, 9, 10, 11. Carry the 1. That's 10. Carry the 1 and 5. So now, when I multiply 293 times 172, I get 50,186. But we have decimals. So now we're at the end. We go back.
Put that little dot.
Okay. Now we count. There is 2 spaces or 2 numbers after the decimal. So I put a 2 there. And this one has 1, 2 also. I'm going to add these 2 together, and that gives me 4. So I take my decimal and I go 1, 2, 3, 4. Okay? That's all there is. You just multiply and then stick the decimal in at the end. However many spaces you have after the decimal in each one, you add those up. There's your answer. Division. Again, we're back to division. The thing to remember when you are dividing with decimal, never divide by a decimal. Just don't do it. Just like when we do dividing fractions and we say, not going to happen. Same thing. We're not going to divide by a fraction. That's messy and awful, and we don't do that. What we do is we change it. Make it whole. Okay, so right here we have 3.8. We're going to move that decimal over one place, and that gives us 38. That's a whole number. But if we do this to the divisor on the outside of the division house, then we have to do it to the dividend inside. Move it over one, same direction. So now it's 2, 3, 0, 2, and 8/10. And just like adding and subtracting, we do keep our decimal lined up. So we just bring it straight up. Now it's just regular division. And of course, it's 38. And we all know our 38 multiplication tables. Right? Wrong. Me neither. So, 38 times 1, 2, 3, 4, 5. So that's 38, 6, 76, 7, 10, 114, and this is 140, 152, and let's see, 5 is 8, 9, 190. Okay, we still need to go further because we know our first number here is 230. So let's do 6, 7, 8. Oh my gosh. Why couldn't I pick a better one? Let's see. So 6 is... Oh, no idea. It's going to end in an 8. 12, 228. And then 6, 2, 3 is 5, plus 1 is 6. And then 266. And then, well, I'm going to stop there because we're good with 6 here, 228. So, because we're going into 230, we have to put our 6 above the 0. Keep things lined up. 228. We subtract, we get 2 left over. Bring down the 2. Up. 38 cannot go into 22. Do not skip this step. You must put a 0 there because it goes in 0 times. Now, if you want to, you can go 0 times 38 is 0 and get another 22. So I'm going to do that just for those that need it. And then we bring down the 8. 38 goes into 228 6 times. Minus 228. We get 0 for our answer. And boom! Drop the mic. That's our answer. 60 6/10. Alright, we're getting there. We're almost to the bottom of this. We got green. And you'll see what these colors mean when you get into math, though. So, prime factorization. First thing, what is a factor? Either yell it out or type it in the chat. What is a factor? Okay, Michael, I need something a little more specific than a number. What kind of number? No, Alexander, it is not part of a fraction, but that is a good guess.
Wait, what was it again?
A factor. It's right there.
Oh, it's like what times this is this?
There you go. Yes. Thank you. A factor is numbers you multiply to get a product. Because remember, product is an answer for a multiplication problem. So now we look at the two kinds, because up here it says prime factorization. So I wanted you to know what a factor was. And now we've got prime. There's two kinds of numbers, prime and composite. Who remembers what a prime number is? You can type it or yell it out.
The main number.
No.
Ooh, prime number. That like the specific number to equal that.
No. You guys, don't let Michael do all the heavy lifting. Hey, there you go, Shalia. Okay? It's not quite right. She put down a number that can only be multiplied by itself. Okay? What we've got is a prime number is a number that has only factors of 1 and itself. Okay? Prime number. You can only divide it by 1 and itself. That's it. Okay? So, like, 2 is a prime number. Because what are the factors of 2? 1 and 2. 3 is a prime number. What are the factors of 3? 1 and 3. Nothing else multiplies to make 3. Just 1 times 3. Okay? So, composite is anything that's not a prime number. All right? So if you remember prime, you're good to go, because if it's not prime, then it's the other one. You don't even have to really remember the word composite. If it's not prime, it's the other word. All right, so let's give you an example. When we factor 12, we want to know what times what is 12. Well, 3 times 4 is 12, right? But when they want prime factorization, that means that they want this big long line of only prime numbers. 4 is not a prime number. So we have to break it down. What times what is 4? 2 times 2 is 4. Well, those are both prime numbers. So now we've got 3 times 2 times 2. Here's something important. When you write down your prime factorization, you always write the numbers from smallest to biggest. So we actually want to write this 2 times 2 times 3. That is your prime factorization. Now I've got 104. And I know your brain just went, hey, that's a big number. Yes, it is. But it ends in a 4, which means it's an even number, which means I can divide it by 2. So 2 times 52. Well, I know that 52 is not a prime number because it ends in a 2, which means I can divide it by 2. So, divide this, and I get 2 times 26. I'm not done yet because 26 is not a prime number. I can divide that by 2 because it's even. So I know that. So this would be 2 times 13. That's my ending because 13 is a prime number and all these other 2's. So now we have to bring everything down. And make sure they're all in number order, and they are. 2 times 2 times 2 times 13. Boom. Alright, now, you notice that both of those were even. I don't want you to think that all even numbers are like that and odd numbers are automatically prime. They're not. Okay, so 117. I know I can't divide it by 2, but I know I can divide it by 3 because I use my divisibility rules. The divisibility rule said if you add up the digits and you can divide that number by 3, then you can divide the whole big number by 3. So 7 plus 1 plus 1 is 9. I can divide that by 3. So 3 times, let's see, 3 goes into 11, 3 times with 2 left over, 27 is 9. Okay, well I know I can divide 39 by 3 again, because 3 and 9, I can totally do that. So times 3, 3 goes into 3 once, 9 3 times. Oh, look at that. So this one is 3 times 3 times 13. I'm almost done, guys. So that's prime factorization. The last thing we have is GCF and LCM. Yes, GCF and LCM. We had so much fun with this. Greatest common factor. We just determined what a factor was. So what are the factors of 8? 1 times 8, 2 times 4. Okay. And then 24 is 1 times 24.
6 times 6, 12, 18, 24. 4.
Yep. 2 times 12. 3 times 8. And 4 times 6. Notice I kept going 1, 2, 3, 4, like that. That's just how I learned how to do it. I find it easier if I go one at a time instead of trying to just pull things out of the air. Because when I pull things out from all over, I always miss something. But if I start with one and work my way up, then I'm usually good. So now we want to know the common factors. We found the factors. Now what's common? They both have a 1. They both have a 2. They do not both have a 3. They both have a 4. They do not both have a 6. They both have an 8. And that's it. So the greatest common factor is 8, because that's the greatest, the biggest thing they have in common of their factors. All right, so let's do the next one. 12 and 30. Okay, I'm going to write this one a little different because you may remember in elementary school it was like 1 times 12, like a little rainbow. Ooh. 2 times 6. Ooh. 3 times 4. Ooh, there's my little rainbow. And then for 30, 1 times 30. Ooh. 2 times 15. Whee. 3 times 10. Wah. 5 times 6. Bloop. And then we look for what's common. They both have a 1. They both have a 2. They both have a 3. They both have a 6. And that's it. So, the biggest one that they have in common is 6. Now, least common multiple is the same thing as skip counting. Too easy. So, let's skip count. 4s. 4, 8, 12, 16. My brain stopped. 20, 24, 28, 36, and 40, and it keeps going. So, dot, 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 dot. 9, 18, 27, 36. Oh, look, 36 and 36. So that's the first one. That means it's the smallest, the least. Common, they both have it. And multiple, we're skip counting. So our answer is 36. Skip counting our 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, and it keeps going. 7, 14, 21. Look at that, 21. Woohoo! Our answer is 21. We're done. All right. Woo! You have been very patient, but this is going to help you if you use it. Okay?